Hi, my name is Haley Sax, and today I'm going to be talking to you about the Beckman rearrangement and the Schmidt reaction, which both create amides. With the Beckman rearrangement, it converts aldoxenes and ketoxenes to amides under acidic conditions with the addition of heat. The way that this rearrangement works is that the R1 group that is anti to the OH on the nitrogen is going to end up bonded to that nitrogen in the amide. Let's go over the mechanism. So first, the OH group is going to be protonated with the acid, and then after that, this newly created water is going to leave. After this, the nitrogen is going to pick up this R2 group, and the bond that was originally to the carbon is going to kick up and create a triple bond between the carbon and the nitrogen. After that, it creates this form right here, but there's also another resonance form that puts the positive charge on the carbon, and this is favorable because the nitrogen is more electronegative than the carbon. Once this happens, water is going to attack this carbon, which is going to give us this product right here. So now a base is going to deprotonate here and form this material. So after this, a tautomerization occurs and creates the amide. Now let's take a look at the Schmidt reaction. This is the reaction of carbonyl compounds with hydrozoic acid or alkyl azides, which is just hydrozoic acid with an R group instead of the hydrogen in acid. So this can be done with all different types of carbonyl compounds like aldehydes or carboxylic acids, but today we're going to look at it with a ketone, which is going to form an amide. Let's take a look at the mechanism. So we start off with the protonation of the carbonyl oxygen by the hydrozoic acid. With the newly created conjugate base of the acid, that is going to attack the carbonyl carbon, and these electrons are going to swing up to the oxygen. Next, the oxygen is going to be protonated, and then these electrons are going to shift to form a triple bond between these two nitrogens, and then these are going to swing onto this nitrogen here. In the next intermediate, the water is going to leave, and the electrons are going to swing down on the nitrogen to form that double bond with the carbon. Now we have this intermediate in which these electrons are going to move so that the R2 group is now bonded to the nitrogen, and then the N2 positive is going to get kicked off. In the next intermediate, water is going to attack the carbocation. Now we are left with this intermediate in which the base is going to deprotonate the oxygen, and these electrons are going to swing up. Now we're left with this, which is going to be tautomerized into the final amide product. And that is the Beckman rearrangement and the Schmidt reaction.